So let's begin. What's going on, guys? It is David the Intern of S5 Solutions here. I'm bringing you a video on this Inventables CNC table. I believe that they are now, what was it called? Shapeoko? But I'm not entirely certain on that. Either way, I am fixing up this table for my boss. And yeah, let's just get into it. So we've got this controller board in here. It's full of a bunch of stuff. This thing has been sitting around our back shop for a little while now, but I'm finally getting around to it. Actually, the first summer I was an intern, I didn't get around to it, but now this is my second summer back here at S5, and yeah, I'm thinking it's about time. So there's a whole ordeal with this. First things first is cable management is atrocious, but unfortunately I do not have time right now to fix that. And that is literally just because we have a project coming up and we need this to work. So aside from that, I'm actually just going to be plugging stuff in, making it look as pretty as I can without spending too much time, and then using it for a project. And in the future, I might actually bring another video to you guys on making it look pretty. So yeah, anyway, the first thing to do here is to make sure that all of our wires are in the correct locations. So I already know that these guys are all plugged into the controller, and I'm gonna trust the past person to work on this that those are plugged in correctly. But who the heck really knows? Also, I forgot to mention, there's a server right behind you guys, and it's kind of loud, and I'm sorry if you can hear a constant buzzing in the background. It's my bad. There's nothing I can really do about that. In the future, I might get a better microphone, but until then, this is what I got. So anyway, back to this guy. So this motor that's on the gantry here, I don't know if you guys can see it or not. There's a motor right here. It is a 48-volt motor, and that is powered off of this DC power supply, which is running through this motor controller into the motor. We also have all 4 of these stepper motors, which are running off of this Arduino-powered Gerbil controller, which is going to be running off of its own power supply. Here, the wires coming out of it are just temporary. I'm actually going to be connecting some better leads. This thing says it can take 12 to 30 volts. Assuming that the motors can take whatever power this thing pushes out at that voltage, I'm hopeful of that. I'm actually going to be hooking up a 24-volt power supply because it's what we have, and I hope I don't blow anything up. Who really knows, am I right? Anyway, first things first. Where's my little screwdriver? Of course, the one screwdriver type I forget is a Phillips head. You know what? These things are combined types, so it doesn't matter anyway. Gonna unscrew the power into this board and get that out of here because who needs it? Anyway, now there's this little green wire sticking out here. Unfortunately, I don't actually know what that's for, and so we're just going to take that out. There she goes. And let's just pick that up. I'm also kind of limited in my tools, you know, so don't make fun of me, alright? I don't have everything here, I just got what I got, and I don't throw a fit, you know? Anyway, so this is going to be powered off of this power supply here. So let's just, yeah, let's just drape that over there. Doesn't matter anyway. Next thing's next. I have a couple of wires over here that I want to use because they're just left over. I like to reuse things when I can, you know. Don't always have to, but it can be nice to, really. So these were all pre-labeled, but who cares? Not my job. My job is to get this thing working and get it working well. Anyway. Yeah, sure, well, there's a little bit of heat shrink on here left from whoever did that previously. We can leave it. It looks pretty. I'm not going to do it in the future, but at least for right now, you know, it looks pretty. Why not? In the future, I'm planning on actually sleeving everything with this kind of cable wrapping material. I can't remember what it's called. whatever plastic it is. Anywhoozy, let's see, this is approximately, let's take a guess at 18 gauge. Is it gonna work? Hey, I got it right. Okay. 18 gauge. I'm doing approximately 1/8 of inch to 1/4 inch of stripping. Doesn't really matter how much, it just has to fit in the terminals, so whatever. Anywhoozy. There we go. Nice and pretty. Now, normally I would solder these ends, but I want to try and get this done today, and so that's not going to happen. So on this board, which I believe this is the Shapeoko 1, don't quote me on that, truly no idea what it is. I just know that we've had this for a little while in the shop here, and we need to use it now. And one of the things is, this will actually really help us get a feel for one of our designs. So a client of ours is going to be sending a rod, a plastic rod, out to a machine shop to get machined. And I've been doing all the mechanical design of that. But one of the issues is, while I've been trained in school on how to machine things, and I'm certified at my school's machine shop, the issue is, you just never know until you give her a try. So I'm going to be giving her a try and trying to actually machine the rod. It's only a 3/4 inch rod, right? But I'm going to be trying to machine it to make it look all nice and pretty on this guy right here. And if that turns out nice, then I know that I can send it off to the client as a respectable design so that they can send it off to machine shop and it'll work nice and hunky-dory. You know, if it doesn't work here, it's either something wrong with what I'm doing to this machine or my design's just bad, which, you know, that's alright. That is perfectly okay. You know, you always run into some things like that where, oh, my design didn't work, I don't know what to do. Man, just take a second and breathe and come up with a new design. You know, nothing can ever be set in stone. You know, some companies will say, oh, it has to be like this. You know what? If you're taking the time to learn how to do something and you want to do it right in the end, then by golly, take your time. You know, I like to get things done fast, but one of the things is, you know, even for me, there's sometimes where I gotta stop, tell myself, hey, David the intern, wait, you know, is this what you want to do? Is this the idea that you have? And, you know, sometimes it is, and I present to my boss, and he says, oh, you know, let's try this other thing. And I said, great. So that works out nicely. Just tighten these down nice and tight. Oof, that red one is poking out. Sorry if you guys can't see super well. I'm still getting used to this camera that my boss loaned me. You know, nothing's ever perfect. I'm not perfect. You're not perfect. Who cares? Okay, did that work? Oh, the black wire's coming out now. Gosh dang, man. Finally! Great. Okay, that's awesome. So, you know, I'm just going to leave these sort of dangling as is. In the future, like I said, I'm going to cable wrap all of these. Yeah. Until then, I've just got this to work with. So that's the power into this motor controller shield. So that's running off of an Arduino running a modified version of Gerbil. This Arduino is old enough that it doesn't actually have enough memory to store all of Gerbil on it. So it's got a very, very heavily modified version. And it's going into this controller to go out to all the motors. In the future, plan is to add end stops so that the CNC machine knows where it is. Otherwise, things won't be super nice. But you know what? That's a future me problem. Anywhoozy. So this spindle, at the moment, does not actually have a speed control from the controller. Now, this board does. And I've been talking with my boss, I've been talking with my coworkers about, you know, how do I connect this to here if this needs a PWM signal to turn the motor? Well, if this does not have a PWM signal out, at least to my understanding, you know, if you happen to know if this thing has a PWM signal out, comment in the YouTube video, please. I would love to know. Well, let's see. I'm going to take you guys through my thinking process here. You know, this is kind of an interactive video, kind of not. I'm talking to a camera, so who really knows, am I right? Anyways, this board can take AC or DC in. I believe it will always rectify any AC into DC, so it doesn't really matter. Don't know. But it's a powerful motor controller. This is not a servo motor that is on this gantry here, so it's just a DC motor. And ultimately, if this needs a PWM signal in, and I don't know if this has a PWM signal out, I don't know exactly how I'm going to control it. And I've been trying to look through the documentation ultimately, and there's not much there. It's really almost strange. You know, this I think it's just because it's old and, you know, the people aren't supporting it as well, but what do I know? I'm just the intern. Anyway, let's get these wires nice and pretty. You know, there are tags on here. Who needs them? I sure as heck don't. And that one I kind of messed up a little bit. Just a nice pair of side cutters. You know, doesn't really matter what you have. You know, work with the tools you got, really. Anyway, so that's going to run straight into this board. So I'm going to strip these wires. That's a 1/4 inch probably. Yeah, why not? Anyway, oh, these ones are only flathead. Great. So this right here, this is power in, this is PWM, and this is motor power out. So I'm going to run from my 48 volt power supply into this guy and out of here into my motor. And so one of the things is, if I don't have a PWM signal, I've been told that we can just run the motor full tilt and the controller doesn't need to control it. And if that's the case, then great. If this thing does need a PWM signal, what I might just do is I might just get another Arduino to generate a PWM signal out. Or if, actually, you know, I'm not even going to try modding the firmware on here. I'm a mechanical engineer, kind of a little bit. I dabble in electrical engineering. Programming is not my shindig. But, I mean, I know how to work with Arduino. I'm just not good with, you know, files that are flippin' massive, really. Anyway. So, I believe, according to the little words on this board here, that black belongs on this side for the motor. But, of course, you never really know. Well, I say that too much, I guess. Okay, so I'm going to use, because we have it, and because I want to, and because nobody's here to stop me, some really nice power cable to connect up this guy to this guy. Now, sorry, Craig, but you're in the other room having a team meeting, and I'm in here recording. So, thanks. Anywho, you guys think, green and black, white and black? You know what? This was originally for a conduit in our shop area, and it was for a power outlet, and we just salvaged it. But ultimately, I'm thinking it'll look pretty with white and black. Definitely got to keep the black because negative. But you know what? White. Green was for ground, of course. I guess white was for neutral. Black for hot. I believe that's the North American standard. You know, all these stupid standards get me so confused, my guys. That ain't gonna work. Let's see. Do I have any nicer cable strippers? Oh, man. Okay, I'll be right back. I gotta go grab some cable strippers that can actually handle that wire. Stay there. Alrighty, there she blows. Some nice cable strippers. These guys can take 10 and 12 gauge, apparently. So, I don't know what gauge this is. Let's see. Let's find out. It's always nice to know things. 12 gauge! Great, so this might even be able to go in the slightly smaller spot. Let's find out! Yeah, it fits in the smaller one, so that's awesome. I'm only going to strip off maybe, again, 1/4 of an inch to 1/8 of an inch here, just because I want it to look pretty when I plug it into here. There you go. The other ends I'm actually going to strip off a little bit longer because I've got these nice little crimps that I can put on to hook up to the power supply. Now, one of the things that I've always wondered, they put, you know, what is it, like 6 terminals just for voltage on these power supplies here. And, yeah, no, I understand why you might want a lot of terminals for, you know, your ground rail or something, or maybe vice versa, your power rail. But, you know, why do I need 6, man? That's just the way it is, I guess. Ah, come on. This stuff is some really thick insulation. There you go. That's the way she wrote it. So, it doesn't... I don't think it directly says positive or negative. I mean, it says ACN, so I'm assuming it's bipolar. But, you know, I don't really know. So we'll just go with it. Anyway. Ah, come on! There you go. These wires are so bouncy that, well, you guys can't see it, but there's a little whiteboard off to the side here. And this thing is long enough that this was acting like a hook and catching on the other end. So I'm going to assume... Oh, I got to open that up first. I'm just going to say that it goes the exact same way that the motor does, because that looks pretty. And by golly, if my mom has taught me anything in life, it's pretty is awesome, I think. Either that or I haven't been paying attention. Alright, that's tight enough. And this one in there. So, there's no real reason why I'm using this big, heavy gauge wire for the input, but this thinner, small gauge wire on the output. It's really just, you know, work with the tools you got. This wire just so happens to be connected to the motor. I mean, this motor has some big, thick stuff coming off. This is probably 14 or 16 gauge, but I think this is actually, you know, 18 gauge. Yeah, actually, no, I was stripping it with the 18 gauge stripper, so yeah, this is 18 gauge, definitely. I think this is probably 14 gauge. This stuff is 12, so just going up the ranks, I guess. Oh, yeah, I forgot about that. Moving this thing, because it's a motor, and I mean, motors are generators no matter what way you put it, in some way, it was generating a very small amount of power to power this board. And while the clock runs, it drains a little capacitors. That's fun. Anyway, I don't think I need this much wire. However, one of the things is, this is some really nice wire, and I want to keep it at least in half-decent shape, so that when I do come back to complete this setup, I can take this wire off and reuse this wire in the future, and instead put, you know, some similar 18 gauge or something, or whatever. But until then, nobody is here to stop me. I'm going to go probably with a little bit more last time, maybe 3/8. Ah, come on. There you go. Now, this little CNC table is actually pretty accurate, so I've been told, but you never know. You know, comment down below if I say you never know too much or anything of that nature. Really, this is one of the first times I've ever recorded a video like this, and I want to see how it works out. Okay, so this actually fits beautifully into these little little terminal blocks here, but I'm wondering if I can go size smaller maybe, or maybe choose a red. Are these the exact same? Yes, they are. So what I'm thinking I'm going to do, blue for ground, red for power, And yeah, whatever. So, white was power. Oh, would you look at that? It doesn't fit. Okay, we're just gonna go yellow and yellow. Because I chose stupid large wire. I guess that's my fault. And I'll just, instead of trying to do it in one plug, I'll just do it across two. Anyway. Guess that's what I get for trying to choose some really nice wire that ends up being way, way too big. Come on. There you go. So, let's see here. I need approximately, what, I think this middle size here. Don't really know. Yeah, let's try that. That worked? No, that was just a smidge too tight. Okay, next one. I think that's this end one here. Whoa, what are you? Oh, okay, it's just a different style. Had me confused there for a second. So, butting it up against the end, lining it up nice and straight. Yeah, that looks a little bit nicer. Though, it didn't crimp super tight. Let's see. Yeah, I think that'll be good. We'll try it, and if it fails, then it fails, and you know what? That's alright with me. As my boss says, fail fast and fail hard. And you know what? He's right. Yeah, that ain't gonna work. Okay. So that's 3 wasted. I don't like wasting things, but sometimes you just gotta go with the flow. Is this one? Oh. Okay, so is it literally just not these ones? What the heck's my guy? Does that fit in here? By golly, it oh. No, it does not. Definitely does not. So, okay. None of those fit. So, what I'm going to do... I don't want to do this. You know, I've gone this whole entire time talking about huge, thick wires. Screw it. I'm just going to go with some small, rinky-dinky stuff. I really don't care that much that... I'm just going to do that. Alright, wire, I guess you get to live another day. I gotta start throwing this stuff away, my man. And as my stagecraft teacher in high school taught me, first you roll it like that, then reverse the roll, and that'll stop it from ever getting tangled up. And you just do that pattern for however long your wire is. This stuff is short enough that I don't think it really matters. Anyway, let's just set that off to the side over here. And I'm going to grab some half-decent wire. I'll be right back. Ah! Slammed my knee into this... No, my boss's paramotor setup. Hurt like a lot, man. Hurt a lot. And 18 gauge. You guys think 18 gauge? I think 18 gauge. You know what? Let's just do a lot. Because I accidentally pulled way too much. And when you pull way too much, what's the way to solve the problem? Well, you just deal with it. You use what you pulled. So I pulled way too much. So what I'm going to do is double it up. Because I can. And like I've said before, nobody's here to stop me. Let's see if this stuff will fit. Oh, easily. Easily! In fact, I might be able to fit 2 wires in there. Let's give it a try. Will that fit? Let's hope it does. Oh, beautiful. Beautiful. It's like I actually meant for that to happen. I didn't, but it's like I did. Not even sure this is the right tool, but I pulled out, so I'm going to use it. Nope, that's the wrong size. Man, I am grabbing everything wrong today. I'll be right back. Well, I mean, I'm still right here. I just got to do a couple of things and get into this little cabinet here. And hope I can find a slightly better crimper. This one, no. Come on. Oh gosh. Looks like I gotta get to where you guys are. Can't see a darn thing in this little drawer. Hey, I found a. Wait, are those a good pair? That's not that. Oh, do I have to switch them? Man, why is it always me that this stuff happens to? You know, I prepped for this video, right? And look at it. I ain't got nothing. So you know what? We're just gonna go with these guys and hope for the best. It's not a proper, 360 hexagonal tool, but you know what? It gets the job done. So let's just go with wire. Yeah, why not this? We go with slightly. Let's go with that one. That'll be fun. Okay, is that secured? Yes, yes it is. And to me, you guys can't see, but to me it looks nice. I think. So, pull these nice and taut. Pull them off, and this wire, unfortunately I can't reuse this wire, so that one's going to just end up in the trash in the future. But, yeah, so, yeah, nice little crimps connection. In the future, I'm going to heat shrink that. Just aesthetics. Nobody has to, nobody wants to, it's just aesthetics. Like I said, Mom, you taught me well. So, I mean, the little bits that I'm taking off here are getting everywhere, but in the end, I'm just actually going to clean it all up, so it's alright. Okie dokie, is that all nice and good? Yes, yes that is. So, everyone buys these tools with all these little notches in here, right? Nobody ever teaches you what each one is for. So you use what you got, and I wish somebody would have taught me which one I actually should use. Out of a proper electrical engineer or somebody who uses these things on a daily basis were to come and teach me, hey David, the intern, you use this, and I'll be like, great, thank you. But nobody, absolutely nobody. Wow, that was terribly done. Whew, it's almost an insult to myself for that one. Look at that, pinched way too hard. Yeah, I'm gonna redo it. Gotta make it look pretty in some way. And yeah, not the right tool for the job by any stretch of the imagination, but it works. And as Adam Savage says, who happens to be practically one of my idols, every tool is a hammer. So every tool can do what you want if you put the effort into trying to make it do what you want. Ugh. Click. Come on. Why do I even try? Oh, tore my glove here. I will fix that later today, because our gloves are out front, because nobody wants to enter a building without gloves on. And I'm in perfect agreement with that, but because that, our gloves are in the front of our office space, and not back here where I am currently. So later today, when I'm done with this and I'm done with you guys, I'll go and get that nice and patched up for me. You know, I trimmed this a little long. I'm just going to cut off a smidge just to make it look pretty. There's a trash bin right there. Okay, now if this doesn't work, who really knows, eh? Who really knows? Alright. Come on. You kidding me? You kidding me, my guy? Ugh. Okay. That's a lot better. I promise in the future I'll get better at this. And I want these to be approximately the same length, so... There. That looks good to me. I'm going to spend a quick second here and just clean up some of this stuff, because it is everywhere and I have messed up a couple of times. But like I said, you know, it's okay to mess up. It is perfectly okay to mess up. You just got to recover, you know? If you spend the whole time hitting yourself or kicking yourself in the rear because you messed up, you're not going to get anything done. Instead, like I said, fail hard and fast. That's what my boss always tells me. That's one, and negative, that's the other. Yes, in case you guys can't see super well. Now, I am not any authority on how any of this should be put together. I'm just an intern who likes to build things. And likes to design and likes to be an engineer. And hopefully, in a year, I will get my degree, and all will be well. If I do not get my degree in a year, well, such is life, I guess. But this whole virus thing, you know, you never really know. But, I'm hopeful. My school says it'll be open next year, and, you know, it's May 14th right now. My school says it'll be open. I don't know if it actually will be, but they say they will, so that's cool, I guess. Okay, is that the same? Nice and squeaky. Okay. I have no idea how long I've even been going at this. The funny thing about engineers is, if we're doing what we love, which, by the way, I love my job. I mean, I'm doing something new every day and it's great. But aside from that, if you're doing something new every day and you're an engineer, you know, it's exciting. And when you love your job, it's just, It's amazing. You know, I can't even remember what I was going to talk to you guys about. I think that was it. Yeah. Come on. There you go. Yeah, always give your wires a nice little tug. Yeah, that's why. You want to make sure that they don't come out. If it's able to come out, it's a loose connection. It's going to be higher resistance, as well as overall, it'll come apart. And you don't want that. You really don't want it to come apart after you've put her together. Okay. That's good, and that's good. Those two are golden. Fantastic. And this power supply. Nice. Awesome. Okay. So the other thing I got to do is I actually got to hook up power and ground to these guys. These are just open frame power supplies. Well, they're in a little cage, but they're not super duper safe, but they get the job done. Ultimately, if you need bulk power, they're cheap. So I'm gonna go grab a power plug for that. We have a whole bin of just, you know, power cables for computers and whatnot. So I'm just gonna go grab one of them, and I'll be right back. That's heavy. What do you guys think? Cheap and meh, or long, or what? I mean, we got some cool looking ones over here, but frankly, I don't care. I mean, I prefer not to cut one if it looks in good shape, so take one apart that I can get apart. That's all broken. Like, here, look at this, guys. Look at this. It's literally like a bin of just cables. It's awesome. And if we need one for any purpose, we can just come and grab it. But, I don't like to take things apart if I don't have to, though granted, my parents would widely disagree with that. I love taking things apart, especially when people tell me not to. Unless it's, you know, for work, then I do what I'm told. But at home, by golly, if it ain't broken, take it apart and fix it is my motto. Hey, go! Okay. So, I think I'm going to do this as one unedited cut, because I'm too lazy to edit. But I might edit it out. You know, that's why I'm saying I might edit it. But if I don't edit it, you know, trying to add some commentary where I can. Gosh. I hate ruining perfectly good power cables, but sometimes you just gotta do what you gotta do. And you know, with these, I'm not gonna spend the time to properly crimp them. I'm just gonna go with it, and it'll just work itself out. I really should get a proper pair of wire strippers. But dadgummit, I started without them, and I'm going to finish without them. Alright, come on. Ugh. Yeah, I kind of nicked one of them. Darn it. Gosh diddly dang it. Start over. Okay. Is that better? Yeah, I didn't nick a single one of them. Oh, what? Nope, they're all good. Fantastic. Okay, so this thing needs all three. This thing draws at max power. What is it, like 6 amps from the wall? Yeah, 6 amps from the wall, man. That's a lot. Yeah, it's okay. So 120 volts approximately at 6.5 amps to 48 volts, 7.3 amps. I mean, that math don't sound right to me in terms of pure wattage. I mean, yeah, I know there's a lot of power loss due to inefficiencies, and at a higher voltage, 240 volts, 4 amps, that makes more sense. But that's super inefficient. What is that? That's 120 times 6, it's, 700 and... Oh, math, don't fail me. 720, I believe, right? So, if I'm wrong, somebody will comment down below and I will get a lot of poop for it. And I'm not going to do the half. But 48 times 7, you know what? I'm not even going to try that. I know my math capabilities. Not the same. But I'm just going to do 50 times 7, which is, what, approximately... 50 times 4 is 200... so approximately, what, 400 watts? So in theory, if this thing's pulling max power from the wall and outputting max power, that's like a loss of, like, what, 300 watts? Am I right on that? And, I mean, like, I know that that's just the max power that it can pull from the wall, and it's never going to pull that much unless you're really pushing it hard. But still, I mean, like, it's weird to say that its max can be, 700 or something watts, while its max output can be, 400 or 500 watts. It's like, what? Like, what? Yeah. Anyway. There's not even remotely enough space here. So, I believe live is black. And that's what I'm going to go with. And if it blows up in my face, then you won't see another video from me. If it doesn't, then you might still not see another video from me. Who knows? And there we go. I always tighten down more than you probably should. I just want it to be good, It doesn't hurt. I think the only thing is you could possibly strip the screw or strip the housing or something, but aside from that, it doesn't really matter. Just gonna pull this straight. Ooh, sorry, I bumped you there. Just gonna pull that straight so I can get these wires in without a problem. Okay, and the last one, ground. Of course, it's the last one that I always mess up. There it goes. Okay. Never forget. Flip down the lid. I have been shocked so many times because I thought a power supply was unplugged from the wall or something, and the lid was up, and I was like, who the heck leaves up the lid? And I go and I touch it, and lo and behold, it hurt. So, aside from that, that is power into this, which again, if I don't have a control signal for it from my controller box, I'm just going to jerry-rig one onto here. There's a jumper here, I have no idea what it does. I'm gonna try and power this on. If it doesn't work, it doesn't work. Yeah. Anyway. You know what? I've got an extension lead here. I'm gonna power it on with you guys. Not this part, just the motor. And we will see what happens with that. So, I don't think I can rotate this for you guys. Easily, that is. So, you're just going to have to trust me when I say, oh, the motor's on, and or just listen for the really loud whirring of a motor. I'm gonna grab this extension cord and get this guy plugged in. So right now, you guys are actually plugged into the extension cord, but the camera has a battery. So, I'm going to unplug you. You've still got 2 hours of video left. Or, no, 4 hours of battery. Sorry, I was thinking backwards on that. I got 2 hours video on that SD card at the bitrate that I'm recording at. But, yeah, so I'm going to unplug you guys, and we will continue on from there. So if it works. The power supply should immediately power on. And the motor then should immediately power on as well if this doesn't need a PWM signal. If it does, then I'll have to generate one of those, and that'll be in a later video. So, contact? Nothing. Absolutely nothing. Lovely. Absolutely lovely. Oh. Ah, I don't know if you guys heard that. There was a little beeping coming from the power supply, so I definitely know that power was going into it, which is good, I guess. Yeah. So all this gets put off to the side over here when this thing is running, and you know, this thing can move in all directions as it should. I still have to properly align it, and the other thing is, a lot of people don't realize this with CNC bits. You know, I'm gonna rotate this just so you guys can see a little bit better. Man, that's heavy. Okay, let's make sure I'm not crushing any wires here. Great, awesome. So, one of the things about these CNC bits here is you always want it to be perfectly perpendicular to the surface. You know, if your axis here is slightly cockeyed or tilted, what you're going to end up doing, and I have a bit here. This is going to be over-exaggerated, by the way, but on a close-up view, you're going to end up coming in at an angle. So what you want to do is you want to make sure that your end on your end mill is perfectly perpendicular to the surface to help, you know, make that perfectly straight, and wherever you go, that's exactly where you want it to be. For our purposes, I'm not sure how necessary that is, but I will do that in the future. It's going to be a long, arduous process of trying it out and, you know, then CNCing or using our little dial gauge just to, you know, measure up the length of the shaft and make sure that it's perfectly perpendicular. Yeah. Aside from that, though, I think in terms of the basics, actually, I think I'm done. This thing started a year ago, almost to the date, actually, and I might be able to get it working. But anyway, next video, which is maybe going to be tomorrow. I don't really know. Tomorrow for me, not necessarily for you guys. Next video will be me going over any more issues that I have found, and hopefully working with the software, and trying to get this darn motor to spin with this controller, because I think the issue is PWM. Though I don't know for sure, though. So we will have to see. Anyways, that's really all I have for you guys. Again, this has been David, the intern from S5 Solutions, and I'll catch you guys in the next one. Take care.